Right. So 8.1, and it's coming up, I'm going to talk before I write, okay, is about confidence intervals. And we're going to determine the point estimate and margin of error, which is really simple. There's a formula for it. Interpreting confidence intervals and levels. Again, super easy. It's the same thing over and over and over again. Describe how the sample size and confidence level affect the length of confidence interval. So you guys, you had that in your vocabulary or whatever. How do you like increase your confidence or make your confidence level better or whatever? So explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. All right. So, sorry, that'll probably keep happening. Mr. Shields' class did the mystery mean activity from page 476, and you guys can go back and check that out. It's not a big deal. He asked what the mean was given a set of that. Given this, he wanted them to find what the mean was. The TI screenshot displays the information that the students received about the unknown population mean. Here is a summary of what the class said about the calculator output. The population distribution is normal. How do you know it's normal? Because they used random normal. And its standard deviation is 20. And we know that from right here. Remember, it's mean, standard deviation, and then your n count. We know it's normal because they said normal right here. A simple random sample of n equals 16. I just told you that is right there. And the sample mean, not the population mean, the sample mean is 240.80. If we had to give a single number to estimate, I cannot, sorry, I can't get comfortable up here. The value of M that Mr. Shield chose, what would it be? Such a value known as the point estimate. So how about 240.80? That makes sense because the sample mean should say is an unbiased estimator. So remember, if the sample mean is 240.80, then the population mean is probably also 240.80. We are using the statistic X bar as a point estimator, of the parameter mu. Again, mu is your population mean. As we saw in chapter 7, the ideal point estimator will have no bias, so you would want your mean, your population mean, and your sample mean to be exactly the same with low variability. Here's an example involving some of the more common point estimators. Again, guys, it's going to be a lot of me talking today since we only have an hour of class, so I apologize. Just bear with me. All right. So in each of the following settings, determine the point estimator you would use and calculate the value of that point estimate. So quality control inspectors want to estimate the mean lifetime mu of the AA batteries produced in an hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetimes and hours of the batteries from one such sample. So we're going to start with A. Since we're dealing with a sample, and we're talking about their mean lifetime, we're going to use the sample mean X bar as the point estimator. Again, why? Because we had the population mean in the beginning. How would you find the mean of this data? If I gave you that data, how would you find the mean? Anybody? Given that data, what would you do? Plug it in the calculator. Yes. 1-bar stats, right? So I'm not making you do this, but I want you to know how to do it. So then we would come up with X bar equals 16.718 hours. Again, just trying to save time. This would come from your 1-bar stats. So B says, what proportion P of U.S. high school students smoke? The 2011 Youth Risk Behavioral Survey questioned a random sample of 15,425 students in grades 9 to 12. Of these 2,792, they said they had smoked cigarettes at least one day in the past month. So what would we use? This one's not mean. What is this one? It doesn't give us a mean. What does it give us?
Statistic.
What? Not statistic. No, what is it asking? Is it asking for mean? Think about the things that we've been doing. Do we use the mean? What do they give us? Thank you, the proportion. So we want to use the sample proportion. And remember, we write that as P hat. As the point estimator for population probability or population proportion. Remember, our proportion is what we want over the total. We wanted to know how many students smoked once in the last month. So what we wanted was 2,792 out of 15,425. Which gave us 0.181. So I wanted you to know where that number came from. Right. So again, if you're not sure why we're choosing this, I'm gonna slide it up for a minute, but I'll take it back down. Here was your population, mean lifetime mu. Remember, mu means population. So we want the sample. What's the sample symbol? X bar. Got it? This one said what proportion? P. So we're going to do sample proportion, and that's P hat. So look at C. The quality control inspectors in Part A want to investigate the variability and battery lifetimes by estimating the population variance right there. So what will we do for C? Not the population variance, but?
Just square the standard deviation it gave you.
No. What are we using? Sample variance. What's the difference in the symbols? What does the sample variance look like? Yeah, S sub X squared. Again, as point estimator for population variance, which looks like that. And again, it's set for Part A, so that'd be from your 1-bar stats. So how would we get it? We'd get it from our 1-bar stats. And yes, Kyle, you are correct. We would get our standard deviation, our S sub X, that's on your 1-bar stats, and square it or look at it. I don't know if the square's on there or not, but you can square it and it'll give you 0.441 hours. Again, so the numbers, the A and C numbers came from your 1-bar stats, but I didn't want you to spend 20 minutes putting that data in. Okay. Any questions on that page? All right. Is the value of the population mean mu that Mr. Schill entered in his calculator exactly 240.80? Probably not, because that's actually X bar. We guess that mu is somewhere around that number. Excuse me. How close to 240/80 is mu likely to be is what we're going to look at. Okay, so that's the question that we're trying to ask in chapter 8. How well is our point estimator? So to answer this question, we ask another. How would the sample mean X bar vary if we took many SRSs of size 16 from the same population? The sampling distribution of X bar describes how the values of X bar vary in a repeated sample. Recall the facts about the sampling distribution from chapter 7. All right, so the shape is normal for the sampling distribution. Because the population distribution was normal. What if it wasn't? What did we do to test
The central limit theorem.
That was one way. What's another way? Large counts. It just depended on what you got. Okay, so those are the two ways. When you guys do those, and I didn't take off on this test, but from now on, make sure when you do those, you actually have to write out approximately normal. So that way, then you can move on. But I didn't take off from that because I didn't stress it too much. But always make sure that you write that. So the center the mean of the sampling distribution of X bar. We know that the center, remember when we did our stuff from chapter 7, we said that mu was equal to mu sub X, which was equal to the population mean. So is the same as our unknown mean of the entire population. And again, that's what I just told you that we did last week, okay? So these are not, this is all exactly what you did last week. There's nothing new. And then we did the spread, the standard deviation of the sampling distribution. Of X bar for samples of size n equals 16. So this is coming from that calculator output. Since we know the population standard deviation, we're going to use this formula. That standard deviation was 20, our n was 16, giving us 5. And what do I have to do to make sure that I can take this sample standard deviation? Yep. And we can do this because it passes 10% rule. Okay. And then it shows that same figure again that we've seen before, the population, and then you take SRSs, and then you can see that your mean is going to be here and your standard deviation is going to be there. So same thing that we've seen before. And it's normal shaped. It's just a little bit more centered, okay? Remember, the more samples we take, the less variability we have. So that's what makes it taller and skinnier, okay? Example, the mystery mean. Moving beyond a point estimate, when Mr. Shields' class discussed the results of the mystery mean activity, students use the following logic to come up with the interval estimate for the unknown population of mu. So right here, an interval estimate is what we need to watch out for. Okay, that is what we're going to try to do. All right, the sample mean X bar, which was equal to 240.80, is our point estimate for mu. We don't expect X bar to be exactly equal to mu. So we want to say how precise the estimate is. So that's what we're trying to do. We're trying to get a range of numbers with a % of confidence, okay? And you guys saw that when I say it, you don't know it yet, but you saw it within your vocabulary. So that's why I kind of did vocabulary first, so you kind of get a heads up of what's going to happen, okay? So in repeated samples, the values of X bar follow a normal distribution with mean mu and standard deviation of 5, as in the previous figure. And I showed you how we got the standard deviation of 5. The 95 part of the 68, this is from a while back, 95, 99.7 rule. You guys remember that? All right, so when you have your normal curve, and here's your mean, and your 3 standard deviations. These two, 68% is within 1 standard deviation, and then it branches out again, and 95 is within 2 standard deviations, and then 99.7% of the data is within 3 standard deviations. Okay, so that's that rule. That's okay. It's been a while since we did it, so it's good that we went over it. Lost my place. For normal distributions, says that X bar is within 2 standard deviations, or 2.5 times 10. 2 times 5 equals 10 of the population mean mu in about 95% of all samples of size 16. And it says, see the information below or the figure below, and you guys can see that they just shaded it in. Okay, so they just took this one that I had and they shaded in these bars. That's 95%. Okay. So whenever X bar is within 10 points of mu is within 10 points of X bar. This happens in about 95% of all possible samples. So the interval from X bar plus 10 to X bar minus 10 captures the population mean mu in about 95% of all the samples of size 16. This is a super important statement, probably makes no sense to you right now, but it will. We're going to do these, okay? We're going to come up with these confidence intervals, and I think they're easy to come up with, okay? They're really easy to come up with. So if we estimate that mu lies somewhere in the interval from X bar minus 10, X bar was 240.80 minus 10 gives us 230.80. And X bar plus 10, which is 240.80 plus 10, or 250.80. I'm gonna let you get that for a minute. This is exactly how you're going to say it. You're going to come up with that interval, and you're going to say that the interval containing 230.80 to 250.80 captures the true mean of the population 95% of the time. That's a confidence interval, okay? And so coming up with it is actually pretty easy, but we'll get there in a minute. So we'd be calculating this interval using a method that captures the true mean in about 95% of all possible samples of this size. Okay, if we look down here, they have P minus 10, or mu minus 10, sorry, mu was that 240.80. This was 250.80 and 230.80. And remember, we would have 1 standard deviation right there. This would be 2 standard deviations below This would be 2 standard deviations above. Where did that 10 come from? Remember each one, if all of this is 10, this is minus 1 standard deviation. Each one of these would be 5. Does everybody see that? So it's just showing you that 2 standard deviations was 10 and where that came from. All right, so we're gonna flip it.
So it's not always going to be 10, right?
No. It's based on the standard deviation, yes. And again, they're really easy to find once you get that data. The big idea is that the sampling distribution of X bar tells us how close to mu this sample mean X bar is likely to be. Statistical estimation just turns that information around to say how close to X bar the unknown population mean mu is likely to be. In the mystery mean example, the value of mu is usually within 2 times 5, 2 standard deviations, or 10 of X bar for SRSs of size 16. Because the class's sample mean was that 240.80, then the interval 240.80 plus or minus 10 gives an approximate 95% confidence interval. And that is for mu. Now, I will tell you that as your confidence increases, your interval will increase. Okay? As your confidence decreases, your interval decreases as well. Okay? So there are several ways to write a confidence interval. We can give the interval for Mr. Schill's mystery mean as what we just wrote, 240.80 plus or minus 10 as 230.80 to 250.80. So that's one way. So when you write your confidence statement, you can write it like this, or you can write it as a coordinate 230.80 comma 250.80. I do not care. I typically just write 230.80 to 250.80. It's the same thing. I mean, it don't take any more to write. So all confidence intervals will have will meet the form similar to this. So you need to know this. It's going to be the point estimate plus or minus the margin of error. In our case, we did the standard deviation times 2. Why? Because we did 95%. 95 is your typical. You'll get 99 as well, or 98. Okay, so be ready for that. Typical is 95. All right.
So if you were to have the 99, would you multiply by 3 instead of 2?
Yeah, we'll talk about it. All right, the point estimate X bar equals 240.80. In our example, should say is our best guess for the value of the unknown parameter. The margin of error, which was 10 in our case a minute ago. How did we get that? 2 times the standard deviation. Shows how close we believe our guess is based on the variability of the estimate in repeated SRSs of size 16. We say that our confidence level is about 95% because the interval which was X bar plus or minus 10, catches the unknown parameter in about 95% of all possible samples. All right, so definition of a confidence interval, margin of error, and confidence level. So guys, these are two different things. Interval and level are two different things. Make sure you know that, because it's going to ask you to interpret the interval and it's going to ask you to interpret the level at some point. All right, so a C%, and that percent can change, and they'll tell you what it is. Again, typically it's going to be 95. Confidence interval gives an interval of plausible values for a parameter. The interval is calculated from the data and has the form. We've already wrote it one time. Point estimator plus or minus margin of error. And again, that's that formula up there that I just wrote. The difference between the point estimator and the true parameter will be less than the margin of error. Okay, if you don't know what MOE is, margin of error, maybe write it out, in C% of all samples. So then this is the first time really hearing confidence level. The confidence level C gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. So still working with that same example, the interval that we just got, the 230.80 to 250.80, gives a set of plausible values for Mr. Shields' mystery mean mu with 95% confidence. We wouldn't be surprised if any of the values in this interval turned out to be the actual value of mu. Remember though, plausible does not mean the same thing as possible. You could argue that just about any value of a parameter is possible. A plausible value of a parameter is a reasonable or believable value based on the data. So there's a trade-off between confidence level so the 95%, it might be 98%, it might be 99%, and the amount of information provided by a confidence interval. We usually choose a confidence level of 90% or higher because we want to be quite sure of our conclusions. The most common confidence level is 95%. Now, will they throw a 90% in there? Absolutely. Okay, so be ready for that. Interpreting confidence intervals and confidence levels. Our 95% confidence interval for Mr. Shields' mystery mean was 230.80 to 250.80. How do we interpret this interval? And this is what we say. So this is what you need to know. Okay, so it's going to ask you, interpret confidence interval. Interpret confidence intervals. This is the one right here. Okay, we are 95% confident. Okay, that 95 could change depending on what they give you. Okay, so that's a variable right there. That the interval from 230.80 to 250.80. That is another variable in this. Captures. And then the last one is in context of the problem, whatever we were trying to capture. In this case, the mystery mean chosen by Mr. Shield. Also variable. That's context of the problem. So that very last part is going to be what we were looking for in context of the problem. So again, to interpret a C% confidence interval for an unknown parameter, we say we are C% confident that the interval from X bar minus 2 standard deviations to X bar plus 2 standard deviations captures the whatever parameter we have in context of the problem. So that's exactly how you write it every single time.
I have a question about using one of our stats in the calculator.
Okay.
S of X and standard deviation of X, when you go to it, are slightly different. So which one is which?
When you're doing this, you want to use, like, and you're trying to find the variance or whatever that we just did, you're going to use the S one.
Are they both standard deviation or is one?
I didn't hear what?
Aren't they both standard deviation?
They are. They are. All right. Interpreting a confidence interval 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, we are doing a 95% confidence interval for the population who favor candidate A. The interval was 0.48 to 0.54. What does that mean? That between 48% and 54% voted for candidate A with 95% confidence. That's what we think, okay? So interpret the confidence interval. Remember what I just said. We are, what's our percent? 95% confident. That the interval from 0.48 to 0.54 captures and what does it capture? These are percentages, 48% and 54%. So it's the true proportion of all registered voters Why is it all? Remember, we're talking about the population, so it's got to be all. It says right here, it's the confidence interval for the population who favor candidate A. All right. So when you go do your homework and it asks you this question right here, reference back to this one. How do we find a point estimator? So what is the point? Should say, what is the point estimate that was used to create the interval? What is the margin of error? So we want, remember that point estimate plus or minus margin of error. So remember that formula right there. We want to find the two parts of that. So the point estimate is going to be halfway between. Remember, our other one is plus or minus 10, so we had to find the middle of that. So our point estimate is always going to be halfway between. So how do we find that? We take 0.54 minus 0.48 and divide it by 2. That's 0.06 divided by 2. Which is plus 0.03. This is your margin of error. How do we find the actual point? We either take the big one and minus the margin of error, or we take the little one and add. You do not have to do both. Okay, you do not have to do both. You do whichever one you're comfortable with doing. So both of these are p hat. So your margin of error is found by dividing in half. If you can already see it, what comes between 0.54 and 0.48 is 0.51, okay? So don't stress too much about that. So the point estimate is 0.51, margin of error is right there. C, based on this poll, a political reporter claims that the majority of the registered voters favor candidate A. Use the confidence interval to evaluate this claim. You will have to do this. So think about your confidence interval. It went from 48% to 54%. So political reporter claims that the majority of registered voters favor candidate A. What would a majority be?
Half.
Not half, but
Above half.
above half, right? Okay, what's the problem with this interval?
It goes from under half to over half.
Right. So here's what it is. Any value, I'm going to write this all the way out so you can see it. From 0.48 to 0.54 is plausible. It's what we just said, since we have values. Less than 50%. We can't say there's convincing evidence. Okay, so what if my interval was 0.51 to 0.61? Yes, because everything is above. So as long as it's above or it is included in that interval, there's nothing below, we're fine. What they'll give you is like a, I don't know, like 68%. And if it's not in that interval, we can say there's not convincing evidence, okay? So you're gonna see this more as we go through this chapter. All right, if we flip it, we have an activity, but we don't do any of those. This is on page 482 if you want to go look at it. And it's just talking about confidence intervals, and this is really hard to read, but this is going to summarize it. As the activity confirms the confidence level is the overall capture rate if the method is used many times. So what they did is they did a bunch of them, okay? The following figure illustrates the behavior of the confidence interval of X bar plus or minus 10 for his class, for his mystery mean. Starting with the population. Imagine taking many SRSs of size 16. The first sample has X bar equal to 240.80. So that's what you can't see. Each one is right there. Each one is a different one. The second has 246.05. And the third has 248.85 and so on. The sample mean varies from sample to sample. But when we use the formula, X bar plus or minus 10 to get an interval based on each sample, 95% of those intervals capture the unknown population mean mu. So all of these, the little dots that you see is actually where 240.80 is, and it's within that line, which is your plus or minus 2 standard deviations, okay? So it's really hard to read because it's really light, but that's what it's saying. And then it puts it into a normal curve for you, okay? Flip it over. The next figure illustrates the idea of a confidence interval in a different form. It shows the result of drawing many SRSs from the same population and calculating a 95% confidence interval from each sample. So this time, instead of doing it from the population, they're doing it from the sample. The center of each interval is at X bar and therefore varies from sample to sample. The sampling distribution of X bar appears at the top of the figure to show the long-term pattern of this variation. And the 95% confidence intervals from 25 SRSs appear to below. So here's the sampling distribution. These are 25 SRSs and the confidence intervals from those samples, okay? The center X bar of each interval is marked by a dot. So you guys can see there's the center of each bar, each dot. The distance from the dot to either endpoint of the interval is the margin of error. Again, you should know that. That's the point estimator, so everything should be equal on either side. If you look at them, and you could really see them on your notes, you can look in your book and see it. 24 of these 25 intervals, which is 96%, contain the true value of mu. If we took many samples of about 95% of the resulting confidence intervals would capture mu. So this one just has 96% because we only took 25. The more we take, the closer to 95 it's going to be. All right, so those are confidence intervals. The next part is going to be confidence levels. So interpreting confidence levels. To say that we are 95% confidence is shorthand. For if we take, this is it right here. If we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter value. So know the difference between confidence interval and confidence level. The confidence level tells us how likely it is that the method we're using will produce an interval that captures the population. If we use it many times. However, in practice, we tend to calculate only a single confidence interval for a given situation. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. So it does not tell us the same thing as the confidence interval. What it does tell us is it gives us a set of plausible values for the parameter. The interval does. Okay. All right, so back to the same thing that we started with. It says the confidence level, watch your vocabulary, confidence level in the mystery mean example, which was roughly 95%, tells us that if we take many SRSs of size 16 from the mystery population, the interval of X bar plus or minus 10 will capture the population mean, mu, for about 95% of those samples. Be sure to understand the basis for our confidence. There are only two possibilities. The interval from 230.80 to 250.80 contains the population mean mu. The interval from 230.80 to 250.80 does not contain the population mean mu. Our SRS was one of the few samples for which X bar is not within 10 points of the true mean mu. Only about 5% of all samples result in a confidence interval that fails to capture mu. So again, we're 95% confident, so there's 5% that could be off. We cannot know whether our sample is one of the 95% for which the interval X bar plus or minus 10 captures mu, or whether it's one of the unlucky 5%. The statement that we are 95% confident that the unknown mu lies between 230.80 and 250.80 is shorthand for saying we've got these numbers by a method that gives correct results 95% of the time. So not always, but pretty dang close to always. All right, so this is what's the probability that our 95% confidence interval captures a parameter? It's not 95%, so that is not our probability. Before we execute the command, and this is the same thing that he gave them, so mean, random norm of M and 20 and 16. We have a 95% chance of getting a sample mean that's within 2 standard deviations of the sample of the mystery population mean mu, which would lead to a confidence interval that captures mu. Once we have chosen a random sample, the sample mean X bar either is or isn't within the 2 standard deviations of mu. And the resulting confidence interval either does or doesn't contain mu. After we construct a confidence interval, the probability that it captures the population parameter. So here's your answer to that question. What's the probability that it captures it? Is either 1 because it does, so 100% it does, or 0 that it doesn't. There is no in between. We interpret confidence intervals and confidence levels in much the same way, whether we are estimating a population mean, proportion, or some other parameter. I'm on Zoom. All right. So our example, do you use Twitter? Interpreting a confidence interval and a confidence level. The Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults. Do you ever use Twitter or another service to share updates about yourself or to see updates about others? Of the sample, you need to know this, 19% said yes, According to the Pew, the resulting 95% confidence interval is 0.167 to 0.213. Interpret the confidence interval and the confidence level. So this, I just leave those off so you guys don't go ahead of me. But again, we're just interpreting. So that's it. You don't have to do any work. So we're going to start with the interval. Remember, the interval starts with we are, whatever our confidence level is, 95% confident that. The interval from, you can write it as a point. You can write it as 0.167 to 0.213. Captures. So again, those are the things that vary, and then we're doing it in context of the problem. What were you trying to capture? The true what? It should always say the true. We had 19%. So what is that? Is that a mean? Is that a standard deviation? What is that? It is a proportion. Now, in context of the problem, what were we looking at? The true proportion that what? Of all U.S. adults. Why do we say all U.S.?
It's the population.
Good, it's the population. All U.S. adults who use Twitter, and I'm gonna dot it right here, or another service to share updates about themselves or to see updates about others, but I'm not gonna make you write all that out, okay? So,
Does it just give us a confidence interval? Like you didn't find that somehow?
correct. Right now, all we're doing is knowing how to interpret them. We will work tomorrow, the next day, how to do that, okay? So we'll stop right after doing the level. And then you guys do as much homework as you can. If you are not on Zoom and you watch this, do as much homework as you can and turn in what you got. If you are here on Zoom and in class, do not turn in your assignment. If you are not on Zoom, you have to turn it in. Got it? Everybody good? All right, so here's your level, because we haven't had one where we just wrote it all out. If many samples of, right here, you're going to write your sample size. So this will vary. 2253, where'd that come from? They took a random sample of 2253. So if we take many of those samples, so if many samples of 2253 U.S. adults were taken, so again, this is context of problem. So all of this would be variable. The resulting confidence interval would capture the true, and again, what we were trying to find, proportion, this is the variable part, of all U.S. adults who use Twitter, blah, blah, blah. For about 95% of those samples. And again, the 95 would also be variable depending on what your level was. So this one was a 95% confidence level. If it were 99, you change it to 99. Only thing we haven't done is this little paragraph and the check your understanding, so you should be able to do your homework. I would do as much as you possibly can. I think that you can do it all. Okay, if you get stuck, we'll talk about it tomorrow. It's not a big deal. Again, hopefully people are watching this. If they weren't on Zoom, anybody that wasn't on Zoom that asked you guys, they have to turn in something tonight or it will be an absence. Okay, they have to turn something in.
Can I get the 3 last
Mhm.
blanks on the last page?
Mhm.
Or the people that can listen?
I'm gonna go ahead and stop recording.